Hi, welcome to All About Mechanical Engineering. In the previous video, we have discussed the general form of steady flow energy equation. Now, in today's video, we will apply that same steady flow energy equation to a particular device, which is steam turbine or gas turbine. For both the cases, the equation remains same. Now, before going to the equation and deriving the equation particularly for steam turbine or gas turbine, let us try to understand what is a steam turbine or a gas turbine. What is the function of this device? As we all know, it is used for producing mechanical work. So, steam or gas which is being entering from this side is used, or the pressure energy of this steam or gas is utilized to produce mechanical work. So this is the only output, or this is the only objective of using this device. So here W is equals to positive because it is produced. As per sign convention, when it is produced, it is positive. So it is not zero, it is positive. Now in case of a steam turbine or gas turbine, heat is neither supplied to the system nor being rejected by the system. So here Q is equals to 0 because heat interaction is not there. Now some may have a question in their mind that there might be certain amount of loss of heat of flowing fluid from steam entering into this system and then leaving. So that is not going to be considered because we are not calculating, we are not supplying any amount of heat, nor we are rejecting any heat from the system. So Q is equals to 0. Now the third point, here as compared to the total height from the datum, inlet height and outlet height are not that much different. So here the changes in kinetic energy or potential energy if you are talking about, so from this is the Z1 and this is, let us say, this is Z2. So as compared to the change in enthalpy, this changes in potential energy are negligible. So if this is positive, this is 0. Let us now try to understand the general form. We have derived already the general form. General steady flow energy equation is given by Q minus W is equals to half into V2 square minus V1 square plus G into bracket Z2 minus Z1 plus into bracket H2 minus H1. This is on unit mass basis. So this is the equation. Now substituting these two values, so W will be there and Q will not be there. So if you try to put the conditions here, 0 minus W is equals to half into V2 square minus V1 square plus G into bracket Z2 minus Z1 plus into bracket H2 minus H1. Now here as compared to the change in enthalpy of the system, these two changes can be neglected. So here I can write neglecting changes in kinetic energy and potential energy. We have here minus W is equals to H2 minus H1. Multiplying by minus 1 on both sides, we get W is equals to H1 minus H2. Now what does this indicate? This indicates that whatever work has been produced by the turbine is nothing but decrease in enthalpy of the flowing gas or steam. So whatever working substance you are using in this turbine, its enthalpy has been reduced, and that the decrease in enthalpy has been given out as work for that turbine. So this was all about steady flow energy equation for a steam turbine or a gas turbine. Hope you have enjoyed this video. Please like, subscribe and share our videos with your friends and stay connected with us. Thank you for watching this video.